Hi everyone, welcome to this session on what is GIS, part of the 2023 Research Methods eFestival with NCRM. This is a recording partly in case my internet dies during the session and we have to jump to this, partly as a resource if anybody wants it in the future, and partly as a test run to see how my timing is. So while everybody kind of files in, please do fill out the poll on Hoover or just type in on the chat on Zoom. So kind of what area or subject do you work in, and have you heard of or used GIS before? Wonderful. So I'm going to talk a bit about what is GIS in this kind of broadest sense. So we're going to talk a little bit about how we might use GIS in research, give a range of examples, talk about some of the pros and cons of GIS, talk a lot about data because that's vital to what we do, talk a bit about software and some of the kind of common problems. We'll say a little bit about next steps as well. And then we've got a little bit of time at the end for case studies and some questions. So in the event, I will ask people to fill this poll in either before the session or during it. Currently, we've got a few answers on the Hoover platform. So people doing stuff with population, cognition, clinical communication, nursing, job quality. So there's a huge range of different areas of people here. And in terms of whether people have heard GIS before, 3 people have not heard of it at all. 5 have heard of it but not used it, and 2 people have used it. So there's lots of potential for things we can do with GIS, and I hope to give you a few ideas over the next 25, 30 minutes or so. So GIS is it's Geographical Information Systems, that's what it stands for. I like to think about it as fundamentally turning data, so this is data with some sort of spatial or location element, and we'll talk more about that later on, turning that into information. So something we can actually do something with. So we use this information to answer our questions, our research questions, if we're working in academia, or any other sort of question that we might be interested if we're in a government, commercial, third sector setting. And these can be any sorts of questions. So there's a huge variety, but I like to put this up front because what this question is vital to a lot of the stuff you do with GIS. We'll talk a bit about this in the case studies, but one of the first questions when people ask me something about GIS is I often get them to think about what is your research question? What are you trying to find? And that's the key starting point, We've got a very general example, where groups of patients more likely to be suffering from obesity. That's an inherently geographical question. They don't have to be, but often the where is really important. And it's often said that nearly all human activities and decisions involve location, involve geography, the kind of where element. Some people even put it as high as 80% of commercial and government decisions involve location. So GIS is a key tool to this. But working with spatial data is very different to working with, say, an Excel file or something like that. So we have to keep that in mind when we're dealing with this. This is why we need our specialized GIS software to organize, to store, to access, retrieve, and so on. But ultimately apply the solution to our problem, to our question. There are a huge range of different areas GIS can be used for, so I'm going to show you a few examples. Some are fairly obvious, some probably a little bit less so. Census data is a really useful source. Possibly this is not an application as such, but it's a really useful source of data for a whole variety of different areas. The military are big users of GIS, whether we like it or not, it's a key tool in a lot of the work they do. This is a really interesting publication called The Red Atlas, looking at how the Soviet Union secretly mapped the world. So this is during the Cold War. The Soviet Union created very detailed maps of capitals of their enemies. So this is an example of Buckingham Palace in London. And there's a great book, and I'd recommend the website if you're interested. We can use GIS in health. public health, that's the John Hopkins COVID dashboard that got very popular during the pandemic. There's a geographical element to that, where are the cases, but there's a lot of non-geographical stuff as well. Planning is another great example of GIS. So this is an example of a dual carriageway development quite close to where I live. Showing this data geographically was key to explaining what's going on with construction, how long it will take, and so on and so forth. Equally, GIS is very useful in politics. So this is the US presidential election from 2020. So this was Joe Biden against Donald Trump. How we represent this data had a lot of interesting discussions. So this is one example of the maps that came out after the results day, looking at it by county. And first glance, you might think Donald Trump's the winner there. He's got more red squares than Biden with blue squares. But it's not that straightforward. In the US presidential system, the electoral college votes are the ones that count. So this is another representation of the same data, this time by state, and the numbers represent how many votes in each electoral college. But, still we've probably got more red than blue on there. We also have these things called cartograms, where we show the proportion of the vote, resize the counties by the number of votes cast in this case. So, this is a different way of looking at the results again, and possibly a more representative way. And, for the record, Joe Biden won the election with 306 electoral college votes against Trump's 232. But this was of much discussion and debate at the time, as you may well remember. We can use it to show crime data as well. So the UK police forces do share some of their data, and you can put this on a map. This is one example from the Our Watch website showing locations of different crimes. Another very common source is the IMD, Index of Multiple Deprivation, which I'll talk a bit about later, but this is a way of measuring social inequality, and we can show that on a map, and we can see that we have certain areas that are more deprived and certain areas that are less deprived. We have weather as well, and we can look at weather in a variety of scales. So global weather, so that's maximum temperature, or at a national level, here's a radar image from a couple of weeks ago, or a more local level as well. So there's a huge range of different options there. When talking about GIS, I thought it would be useful to kind of split things up into 4 different types of map, types of analysis, if we want to think about it like this. So we can start off with what might be a relatively basic map. It's a kind of you are here, a kind of this is your study area type map. Yes, this is basic, but that doesn't mean it's not useful. It's really, really useful. This is a lovely example someone posted on Twitter. So Rebecca Hansen, she was doing a GIS workshop at a conference, and she did this map to show kind of where she's working and what she's looking at. And this is a great way of getting into GIS to show what you're doing and where you're doing it. We can use maps to show data. So these are what we call choropleth maps. So these are where we have the maps with different colors. We can show any sort of data that we want on them. So in the example, we've got the rates of marriage in Liverpool, but we can look at rates of disease. We can look at other census data. We can look at any data you want if you've got the data, which we'll get to in a minute. Those two so far have been quite visual, quite what we might call descriptive. You might think of them in the same kind of vein as descriptive statistics. But we can do some more advanced stuff. So we have spatial statistics. So this is where we start to take some stats and explicitly apply location. So we can have measures of what we call spatial autocorrelation. So is the location of the data important in the patterns that we see? We can talk about clustering, and we can talk about hotspot analysis. And we can apply regression as well. So exactly the same principle as you'd use with regression with non-spatial data. There are types of spatial regressions. So you may have come across GWR, geographically weighted regression, which is quite well, relatively well known. And there are other sorts as well. So this is where we kind of go down the statistics route. Another example is spatial analysis. So this is a slightly different approach. This is using our GIS data to say, okay, what area meets certain criteria? So, the example there is looking at the proposed route for a water pipeline. And we're saying we've got these criteria we have to meet. It has to be within 2 kilometers of a road, it has to be under 100 meters in elevation, it has to be more than 600 meters from a river, and more than a kilometer from the forest area. And then we do all this process and we see the hatching, and these are the areas that meet those criteria. And we can apply this to a number of different places. So we can apply it, say, okay, what are these criteria for a new hospital? Which people have trouble accessing the current hospital? What's the size of the site we need? What's the transport links we need? And so on. We could also look at how do we choose the location for a new railway line or a new railway station or tram station or et cetera, et cetera. And there are lots of different examples we can use this principle with. So these are our kind of 4 different types of maps. So kind of where are you? Descriptive maps, spatial statistics, and spatial analysis. And we can apply this to pretty much any area. So we've had a few examples already that I mentioned earlier, census, military, politics, health, crime, social inequality, and weather. But you can apply it to other areas as well. So some kind of less common examples, mining. So 3D maps of mines are key to managing how people and vehicles and resources and all the rest of it move around the mine. And there's been quite a lot of work in the 3D area. Social networks are another one as well. There's been a couple of presentations on network analysis of various types, and we can apply some geographic analyses to these as well. So this is looking at the relationship between different people in social networks. So whether it's on social media, Twitter, LinkedIn, Facebook, or in reality in terms of relationships between people and so on. We can also apply it in ethnography. So I found this interesting example. It makes us think a bit about how we can do this differently. So here we're looking at, this is someone who is talking a bit about their working environment. So we've got some examples of where they're based, what tools they might use, who else is in the area. We can look at their career journey. So not spatial, but looking at change over time. What are the different stages of their career? How did they relate to each other? Who's involved? And so on and so forth. And on the bottom left, we can also look at an organizational map as well. So how do we look at people in a management structure? Cool. So I'm just going to do a quick poll just to make sure that everybody is still awake and everybody's still okay. So I'm really interested. Have you ever worked with data with location before? And this can be anything to do with location. It doesn't have to be coordinates. So it could be addresses, it could be a point of interest, it could be a city name, it could be a country name, etc., etc. And then also, did you know what GIS was before this session? Cool. So, this is a recording, so I haven't got any results, but I hope we'll have some interesting results on the day. It's worth mentioning that GIS stands for Geographical Information Systems, which is what I've said already, but it also stands for Geographical Information Science. So sometimes these 2 terms are used interchangeably, but they have slightly different meanings. So GIS systems is the existing stuff that we use, the software, the technology, and so on. GIS science is the development of new methods and techniques. So the academic side is called Geographical Information Science, and one of the main journals in the field, IJGIS, is called International Journal of Geographical Information Science. Geographic is probably more US. Geographical is more UK. Take your pick. Geographic data science is another term that's cropped up as well. This is more when data science first became popular. Geographic data science was kind of using some of the data science tools to do spatial analysis. It is still to a degree, but this is mainly focusing around coding, so R and Python, as opposed to our traditional desktop GIS systems. But there's a lot of overlap between the two, so I'm not sure there's a massive difference now. Really important things to remember. I'm sure you've all come across the phrase correlation does not equal causation whenever you're dealing with statistics. The kind of GIS equivalent of that, if you like, is, from my point of view, be critical of maps. So whenever you see a map, just because something's on a map doesn't mean it's true. We need to be critical about what we do with maps and how we interpret them. So the example here, we've got 3 different maps, and in fact, this is all using the same data. And this was some examples of the maps used by the UK government when they were doing some of their coronavirus press briefings, particularly for announcing lockdowns. How we group this data is quite important, and that's the difference between these 3 maps. You know, if we look on the left, the categories are quite small, so they're like 50 units wide, and we've got a lot of dark colours. So, you know, up in the northern England, we've got higher cases of COVID. Whereas on the right-hand side, we've got a different categorization. You know, some of the categories are much larger, so they're about 100, you know, 150, sometimes like that. And here we've got many fewer local authorities in this dark red color. Which is right? Well, you can argue that. There is no right answer to this. Which is most appropriate? Depends what you're doing with it. You know, if you want to use a map to announce that you're having a national lockdown, the middle or left maps are probably more persuasive. But when we look at these maps, we need to think about this. And if you start creating maps, you need to be aware of this as well and think about, you know, how do you represent the data fairly? A great write-up from James Cheshire on this. So if you're interested, do check out the links below. I wanted to mention a couple of terms that I think would be worth knowing if you're interested in getting more into this. So these are projections and coordinate systems. And these are fundamental to how we think about space and how we show data. So the Earth is a 3D object, you know, it's a sphere-ish, but most of the maps we work with are flat pieces of paper. So how do we deal with this? Well, we can think about it a little bit like peeling an orange. Take the peel off an orange, you do not have a flat piece of paper. No way, Jose. You might have something a little bit like this. This process means that we end up having to distort our data from our 3D globe to get our nice rectangle. And there are many different ways of doing this. These are called projections. So the Mercator projection, top left, something you may have heard the name. There's another one called the Peters projection, and one called the Equal Earth projection as well. And they're all slightly different ways of doing this. The key bit is you can end up distorting some countries and continents quite dramatically. So if we look at the top left, Mercator, we've got Africa and Greenland in blue there. They look about the same size, but that's complete rubbish. We know Africa is much, much bigger than Greenland. So why is this? Why have we got this going on here? Well, it's to do with the origins. The Mercator projection was developed in 1569 by a chap called Mercator, which is where the name comes from. At this point, they were doing transocean navigation, so taking a bearing off a map was a vital element, and for that, the angles had to be correct. And as a result, the area got distorted, which is why we see some of these distortions in the Mercator projection. An alternative was come up with by Peters, so that's the top one on the top right, where they distorted the shape but maintained the area. So that's why the area is much more representative, but some of the continents and countries look a little bit odd because they've been kind of skewed to match. The Equal Earth is a different approach where they try and balance both of this. So you distort the area a bit and distort the angles a bit. And there are many, many other approaches to this. I'm not going to go any more into this now, but the key bit is to, you know, just be critical of maps that you're looking at. The other practical element is coordinate systems. So this is how we specify location. So we give a location, a set of numbers, and there are several different systems of those as well. Latitude and longitude being the most common, which you've probably come across. So a certain distance north or south of the equator, and east or west of the prime meridian. So that's the north that goes through Greenwich, London. You've probably also come across British National Grid as well. So these are meters and a certain distance east or north of the kind of nominal naught point off the southwest coast. If you go into this in more detail, there's loads more out there, but I just wanted to mention it in passing. GIS is great. I probably would say that. I'm fairly biased, but it does have some weaknesses as well. And so I want to say a little bit about this. Firstly, data is key. So showing data on a map is doable, but you need to get this data. And we're going to dive into that a little bit in due course. It's worth mentioning in passing, partly because of its origins, partly because of the focus on data. GIS is often seen as very quantitative, and not all applications, not all areas of study are very keen on that. Some things cannot be quantified. There are some approaches to what's sometimes termed qualitative GIS. So how you show some of these non-quantitative data sets and information spatially. But it's worth saying it is very much the kind of junior partner to quantitative GIS. If you're interested, there's the term participatory GIS, which is well worth a look, which writes up some of these. And there's a whole area of participatory planning as well, which has done quite a bit of work in this area. So data is fundamental to GIS, but we need to think a little bit about where does it come from? So how do you find it? And there is no one answer to this. I'm going to share a little bit of suggestions, but there is no simple answer to this. First thing of note is we have spatial and non-spatial data. So the spatial data is the shapes or the units of geography that we're using. So it might be countries, it might be counties, it might be local authorities, it might be LSOAs, and so on. And non-spatial is sometimes termed attribute data. So this is almost like the table that sits behind the GIS, the spreadsheet. So you'd have one row for each of your geographic units. So it might be one row for each country. And then you have one or more columns of data that you are showing. So it could be population, it could be area, it could be life expectancy, infant mortality, blah, 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 whatever you want. There is no one source for GIS data. Depends what you want to look at. So both in terms of geography, so what area, and what theme. If you're dealing with data for Great Britain, Ordnance Survey is the best place to go. They've got oodles of data for Great Britain. Census data is a really useful resource as well. So the UK Data Service has a service for that. Outside that, Eurostat is a really good resource for European level data, predominantly EU, but not exclusively. And there's various other lists as well. So Free GIS Data is a great site for finding data. GeoBoundaries is a good source for administrative boundaries for any country in the world. OpenStreetMap is another useful source as well. And you can also do a Google search so that, there is lots of data out there. Worth mentioning in passing, we have lots of spatial units. So this was a massive poster produced by ONS looking at the UK statistical geographies. There's a link, well, there should be a link on the slide. So that's well worth a look. It can help you work out what's going on. There are lots and lots of units is the key thing here. Countries, is fairly common. Counties is something that we tend not to use a lot in the UK. Local authorities is the kind of nearest equivalent. You get a lot of data at local authority level. Government office region crops up occasionally. MSOA, LSOA, and OA are all census-related units. So if you're working with census data, you'll probably come in those types of units. On that note, census data is a great source for all sorts of applications. So we have population, so number of people by whatever geography you want. But we also have age groups, so 5 or 10-year age bands, gender, marital status, ethnicity, health, and so on. There's at least 100 different variables you can get from the census. So there's a lot of data there. One other thing I thought might be of interest to this audience, particularly, is the Index of Multiple Deprivation, IMD. And this is a way of measuring how deprived different areas are. England, Scotland, Wales, and Northern Ireland all do their own slightly different thing, but it works in more or less the same way. There are 7 what they call domains. So these are kind of things that contribute to this IMD. So income, employment, health, education, access to services, housing, crime, and living environment. And then they're given a measure of how deprived they are. And this is by each LSOA, so lower layer super output area of about 1,500 people. And it can be really insightful to map some of these to see how deprivation varies depending on where you are. So, here we've got the darker blues as more deprived and the lighter yellows as less deprived. And we can see in urban cities, there are areas of more deprivation, areas of less deprivation. The other way of getting data into our GIS is something called joining. So this is where we have our spatial units, or sometimes what we might call polygons, and they each have a unique identifier. So this could be a name or a number. And then we have some attribute table, or what you might call a lookup table. So this could be one or more columns of data that's got high, average, or low in this example, or it could be numeric, numbers of people in this age category. It could be to do with number of crimes, anything you like. And then we have this process called joining, where we can link these two together. And this is often the most common way of getting data into a GIS. We can then color in our areas to represent this data. So, this is what we call a choropleth map. And we can see that we've got an area of high deprivation in the top of this map. Cool. So another question I thought would be interesting. I know some people have used GIS before. So just to introduce a little bit of chat about software, have you used any of these GIS bits of software before? Even just a little bit? Cool. So ArcGIS or ArcGIS Pro is the most common commercial software. There are others out there though. So QGIS is the most popular open source software. So if you kind of dabbled in GIS, you've probably used one of those two. R and RStudio and Python are also relatively common. They are all command line based, or scripting based. So you use codes and you type stuff in rather than using a point and click interface. There are pros and cons to both. It's worth mentioning that the command line stuff is useful for reproducible analysis because that allows people to easily replicate what you did. But all of these bits of software can be useful. Different people use different things. Personally, I tend to use R and QGIS quite a lot in the work that I do. So I wanted to mention in passing some common issues in GIS. So when people are starting out, coordinate systems can be a real problem. And 9 out of 10 problems when you're working with GIS data results from using the wrong coordinate system. And this applies both to people who are new to GIS and people who've been using it for several years. If you get the coordinate systems wrong, it can get very complicated very quickly. So if you get stuck, that's the thing to check. And any GIS course or book that you do will talk a lot about coordinate systems. And this is why, because it's easy to get it wrong. It's also tricky to find the right data. And it's easy to spend a significant chunk of your project, easily 50%, looking for data and bringing data in and doing the data munging to get it in the right form. There's no easy solution to this. It's just, it is what it is, and you have to deal with it. But that don't be surprised if you spend a lot of time fiddling about with data. And finally, postcodes can be a really useful source of location data. If you're dealing with surveys or anything like that, asking someone, what's your postcode, is a quite straightforward thing to do, right? Whereas where you live is a little bit more convoluted. Everybody knows their home postcode. But it does have its limitations. Postcodes are, designed for delivery in post, that's the name. So each postcode has about 10 to 15 houses in it. So to use that to get a location in an urban area, that's fine. As an example, in central Cardiff, one postcode unit, so that's the name for the full 6 or 7 digits, is about 0.6 hectares. So, a few hundred meters, give or take. But in rural areas, it can be massive. It's still 15 houses, but the most rural one I could find in Wales was 5,400 hectares. That's about 20 square miles. So to give you a concept of that, it's about the same size as the London Borough of Ealing. It's absolutely massive. So if you're using postcodes for location, it's fine, but be aware they can vary. So if you're dealing with really rural locations, it could be anywhere in that 20 square miles, the house. So just keep that in mind. A few kind of upcoming developments, things I thought would be worth mentioning. So we've got AI is the big buzzword at the moment. It's not had a huge impact on GIS directly, I would say. There's some stuff that it can do in terms of interpreting satellite data, interpreting aerial photography. Most of that we could do already. It's improved that a little bit, but there's nothing very revolutionary there. For example, it can view a satellite image and it can pick out houses, buildings, water, fields, that sort of thing. But we had other techniques for that, so it's not that revolutionary. The kind of large language models, ChatGPT, Bard, all the rest of it. There's some really interesting learning and assessment challenges for that. So some of the other talks may have mentioned that, but anyone in teaching will have heard a lot about that. But I think there's a lot of potential for this as well. So you can ask it questions about things and get a kind of answer back. You could say, how do I do GIS analysis looking at crime data for Suffolk? And you might get something sensible back for that. I've tried asking it, and some of them are quite good, some of them less so. So take it with a pinch of salt, but it might be a good starting point. Some people have said it's very useful for writing code. So if you're writing some R or Python code and it doesn't work, you can say, here's the code, it doesn't work, help, and it will make suggestions. I've not had a lot of luck with that, but some people really rave about it. So I think it depends how much you put it in, and you have to get your phrasing right. But some interesting things going on there. So where do we go from now? I was going to share some links to resources that you might find useful. If you like books and you're a book person in terms of learning, there's a lot of stuff out there. So there's a book that I wrote called GIS Research Methods, a kind of overview of GIS and how we apply it, part of the NCRM Research Methods series. So the first chapter is available for free. There's a link on there. If you're interested in the cartography side, I'd really recommend this one from the British Cartographic Society, Cartography and Introduction. So they give very good examples of different cartographic styles and what works and what doesn't. If you want to learn QGIS specifically, as Discover QGIS 3.x by Kurt Venke from Locate Press, that does some of the theory, but also lots of practical examples in QGIS. I'm also working on a book using R as a GIS. So the first chapter is free online. The rest of it's in process. So I'm still writing it at the moment. But if you want to go down the R route, I'd really recommend that. If you want to do a training course, there are a number out there. So I'm doing some through NCRM. So there's one introductory ones on QGIS and R in February and June respectively, and then a more advanced one in July. There are other courses out there. There are often courses in a specific field as well. So if you're in health or transport or something like that, there may be GIS in transport or GIS in health or something like that. So this may well be worth checking out. Data links. So there's the free GIS data site and GeoBoundaries. These are really useful links, so definitely recommend those. And if you get into GIS and start creating maps, really look at other people's maps. There are lots of examples out there. You can look in newspapers, academic journals, online, all sorts of stuff. So have a look for other people's ideas. And more often than not, they happily share how they did certain techniques. So there's lots of stuff out there. Particularly now, every November, there's something called the 30-day map challenge, which is run on social media. And the idea is anyone can create maps and post them online with this hashtag. And people share hints and tips and good resources for data and cartography and all the rest of it. So these are a couple of examples. So this was from day 6, which was yesterday, looking at this is examples of metro. So Tokyo's metro on the left, and then a river on the right-hand side in Bangkok. Then there's a different theme each day. So if you do a search for hashtag 30-day map challenge, you'll probably find some great examples. Wonderful. So thank you very much for listening. Thank you for listening to the pre-recording if we end up using that. During the session, I'll talk, happily answer questions and talk about a couple of case studies. So we'll do that. If you've got other questions and it's still the day of the e-research methods festival, feel free to ask stuff on Hoover. And I'll answer some stuff on there. Otherwise, I'm happy to have emails, so please do feel free to email me, and I'll happily answer any questions that I can. Thank you very much.